Alright, so number 8. Explain why a glass will break if you drop it on a hard floor, but it will not break if you drop it on a carpet. Sometimes it won't break. Most of the time it won't break. So why is that? This has to do with the idea of impulse. Impulse and momentum are tied together. So basically momentum, remember, depends on how much mass and the speed that that object has. So for instance, a semi-truck that is driving 70 miles an hour has more momentum than a car driving at 70 miles an hour because the truck has more mass, and therefore it would be much harder to stop. And whenever you do change something's momentum by either stopping it or you could even speed it up, then you are applying what's called an impulse. And that impulse is dependent on the strength of the force that you exert, and that'll depend on how long it takes to slow down. For instance, you have a hard floor and you drop a glass on it. My attempts to draw a glass, sparkly glass. And if there's a hard floor, as soon as this hits the ground, there's going to be a huge force to slow it down. It's going to stop it. It's going to change its momentum very quickly because all of a sudden it's going to come to a stop. Very quickly, probably 0.01 seconds or maybe even faster than that. Whereas if you have a carpet is kind of fuzzy, and if you think about it, it's a little bit thicker than the floor. And so whenever the glass falls on it, then now it's not basically it's going to hit the top of the carpet and it's going to slow it down over a greater period of time. And so the force isn't going to be as much because the force is exerted over a longer period of time. So force is less, but the time that force is applied is more. Right? And so we did that demonstration in class with the egg and the pillow. So we drop the egg on the hard ground, or you throw an egg against the wall, drop it on the ground, it's generally going to break. But you throw it into a sheet or drop it onto a pillow, that it slows it down over a longer period of time, and so the force is less, and so it will not break. Alright, so number 9 is about momentum and calculating momentum. It says, which has more momentum, 10,000 kilogram semi-truck traveling at 10 meters per second or a 1,500 kilogram car driving at 30 meters per second? So you may be inclined to say, well, hey, the semi-truck is really, really heavy, so it's going to have more momentum. Want to be a little careful because the car, while it is lighter, it's traveling faster. It's actually traveling 3 times faster than the truck. So who would win this battle? If the truck and the semi-truck were driving toward each other and have a head-on collision, which one's going to have more momentum to kind of sort of win that little battle? So we can find that out real quick. So momentum, P, is mass times velocity. The mass of the semi-truck is 10,000 kilograms, and it's traveling at 10 meters per second for a total momentum of 100,000 kilograms meters per second. This is for the semi-truck. And for the car, same thing, mass times velocity. The car's mass is 1,500 kilograms, and it's traveling at 30 meters per second. So, what do we have? 45,000 kilograms meters per second. Car. And so indeed, the semi-truck does actually have quite a bit more momentum, that makes sense, than the car does. And I'm not sure if this is an accurate number for semi-trucks. I kind of made that number up. Might be 10,000 kilograms seems like it's a lot. But we'll see. Anyway, that's irrelevant. Number 10. This truck only weighs 2,000 kilograms. It's not a semi-truck. And it's traveling at 5 meters per second when it hits a barricade and it stops in 1.5 seconds. What is the force on the truck? So there's something that we could talk about called the momentum impulse theory. And basically, impulse is found in 2 ways. Impulse is J. You remember that? And so J is it's defined as the change in momentum. So that would mean that it's the mass times the change in velocity, typically. Because these typically masses stay the same, and so you change your momentum by speeding up or slowing down. But momentum, or impulse, as we also talked about up here with the wine glass, also relates to the force and the time that it takes to stop it. So the impulse is also equal to the force times the time that force is applied. So we're going to combine these two to find the force on the truck. So we're looking for the force. So we're going to be looking for this force right here. All right, but we know that it stops in 1.5 seconds. So this is our time. But we don't have the impulse. But what we can do is we can find the impulse by finding how much momentum the truck changed by, basically how much it lost, because the final momentum is 0 because it's not moving anymore. So how much momentum did it lose? So our momentum J is the mass of the truck, our impulse J is the mass of the truck times the change in velocity. So the final velocity was 0, the initial velocity is 5 meters per second, and so the momentum comes out to 10,000 kilograms meters per second. I said momentum again. Gosh, the impulse, 10,000 kilograms meters per second, and technically it is negative since you are losing speed. The sign in this case is not too essential. You would still arrive at the same answer if you got it positive or negative. So now if this was the impulse that it had, or that it lost, the momentum that it lost that momentum because there was a force applied for a time of 1.5 seconds. So what is that force? Well, we can just divide this by 1.5. And so it'll be 2/3, so that's actually 60, that's a lot of sixes, a little unlucky there. So 6,666 newtons of force, and it would be a negative force since it's slowing down. So the amount of force on the truck was 6,700 or so newtons of force. Number 11, talking about energy. I'm just going to switch papers here. So energy, types of energy. We have potential energy, kinetic energy. Those are the two big ones we talked about. Potential plus kinetic, those two combined create what's called mechanical energy. And so number 11 asks, or says, an airplane is flying in the air, and we got the airplane weighs 20,000 kilograms, and it's flying at a speed of 225 meters per second, and the height is 5,000 meters. So part A, what is the plane's kinetic energy? Kinetic energy, 1/2 mv squared. So 1/2 the mass is 20,000 kilograms. So it's 10,000 times the velocity squared. So 225 meters per second squared. I can't do that one in my head. So we got 225 squared is 50,625. 625 times 10,000, which is 4 more zeros. And so we are left with a very large number here, 506 million, or in scientific notation, 5.06 times 10 to the 8th joules of energy. What is the plane's potential energy? Potential energy, U, and I guess I should have specified the gravitational potential energy, is going to be mgh. So our mass is 20,000 kilograms. G, 9.8 meters per second, and the height is 5,000 meters. Another large number. It's going to be near 10 minutes. What do you have? 20,000 by 5,000 by 9.8 gives us, oh wow, I should have been able to do that one. 9.8 times 10 to the 2468 joules. Right? Yeah. mechanical energy is kinetic energy plus potential. So we have 9.8 times 10 to the 8th plus 5.06 times 10 to the 8th. That's convenient. I actually didn't plan for that to happen. I just made these numbers up. But they have the same 10 to the 8th, so that makes adding them very easily. We have 14.86 times 10 to the 8th, or 1.486 times 10 to the 9th joules of mechanical energy. And D, if the plane were to speed up, what types of energy would change? So speeding up, so if we increase the velocity, we have to ask ourselves, which of these would change? So kinetic energy is energy in motion. The faster it's going, the more energy it has. And right there in the equation, you see that it is dependent on velocity. So increasing velocity would increase the kinetic energy. All right. Potential energy depends on the height and the mass and gravity. So that does not affect, or the speed does not really affect potential energy. If the plane were to get higher up, if it were to speed up and go higher, then it's a potential will change. But potential energy does not change. Mechanical energy will also increase, because if mechanical energy is kinetic and potential put together, well, if kinetic increased, then mechanical also had to increase. Alrighty, I think I have time for one more. Number 12. Suppose a plane turns off its engines while it's flying and it starts to fall freely. So plane engines turn off and it's falling down. What happens to the potential energy? So if we were to kind of draw a little plane here real quick. If the plane were to fall down, it would start falling freely. What would be happening? There's no forces, or there's basically the engine is not propelling it. It's not giving it any energy. So we can assume that the energy is being conserved. Granted, there will be air resistance and whatnot, but for simplicity's sake, we have the potential energy as the plane is decreasing its height. Its potential energy is going down. It is losing. So basically, the higher it is, the more it can fall. So if it's not as high, then it can't fall as far as it could have before. So the potential energy is decreasing. So potential energy is decreasing. This is U. Excuse me. U is decreasing. Kinetic energy. Well, if it is in free fall, something that is falling speeds up. It is accelerated by gravity, 9.8 meters per second squared. And so just like if you drop a ball, or if you drop something heavy on your head from right above your head, it might hit it, but it's not really going to hurt too bad. Whereas if you drop it from the second story onto your head, it's going to hurt more because it's going faster, because it's sped up. So as you go down, your kinetic energy is increasing. And again, you are losing potential energy. This potential energy is lost, but it's converted to kinetic. So while you may be losing height, you're gaining speed, so that the total mechanical energy stays the same. Alright, that is conservation of energy, a pretty important principle for sure. Alright, I think I'm going to stop this video here, and part 3 is coming up.